Solar fuel saving solutions with Fronius and Elum energy. Hello everybody, welcome to today's lunchtime webinar. Today we have got a very special webinar. We have got a first time ever partnership webinar with Elum energy. I'm very excited about that, and I'm very happy that we also have Elum on board today. What's the team today? One of the team members you can see live. I've switched on my camera today that you have kind of a face behind the slides and the presentation. So my name is Köhl Sandro. I'm from Team Trainings and Education in Austria at Fronius International at the headquarters. And I also want to kindly welcome my colleagues from Fronius. On my side, there is Mr. David Heineck. He is off-grid and microgrid expert at Fronius here, and he will support me today in the chat, as well as Christoph Schillinger, who is also in the chat and will give you immediate reply to your questions. So feel free to use the question box for any of your belongings. And on the other end of the line, I want to kindly welcome Mr. Lucas Leconte from Elum Energy. Hello, Lucas. Are you still here? Can you hear us?
Yes, Sandro, I can hear you very well. Thank you for the introduction. Welcome, everybody. I'm very glad to be here to present this webinar with you about fuel saving solution for hybrid system. I'm Lucas from Elum Energy, project manager working in Paris office and dealing with all operational aspects at Elum Energy.
Okay, thanks, Lucas. Let's start directly with the agenda. So we have split up the presentation today in two parts. So the first part will be my part. The Fronius part, I will give you kind of a quick introduction to the PV-Genset technology in general. We will talk about common use cases. I also want to present you the Fronius PV-Genset solutions. So we also have the easy solution with genset systems. That will be the key part of my presentation. And then the last part is Fronius and Elum energy. So for advanced and professional solutions, we have got the need to partner up with partners like Elum energy. And therefore, in the second part, Lucas will give us valuable insights into the key compatibilities of Elum energy and Fronius. Good. One beginning slide to Fronius in general. I quickly want to introduce the company. So we are a family-owned business since 1945. So until today, we are in family ownership of the family Fronius. Today, we are in third generation. So you can see this woman here. This is Mrs. Engelbrechtsmüller-Strauß, which is currently the CEO of Fronius. And yes, this year we are celebrating 75 years of Fronius, 75 years of huge success story in PV and solar, and also in our other divisions. That's kind of a quick introduction to Fronius, but I do want to quickly go into detail of PV-Genset technology, because that's of course the main topic for today. So I will give you now a quick introduction to PV-Genset technology in general. So how does a PV-Genset solution look like? What are we understanding under PV-Genset? So on the one hand, these three components or devices you can see here are the most important one when it comes to a PV-Genset solution. On the one hand, it's of course a genset-based solution. So the generator, the diesel genset, builds up the grid. It's the grid format. And we want to integrate in the system the PV system, of course, the Fronius PV system, in order to supply our loads and to supply the energy demand. We want to meet it and have at all time energy. When we talk about PV-Genset solutions, it's generally all about the interaction between an inverter and the genset in order to guarantee at any time, at any situation, the correct energy flows to our loads. Yes, and typical genset use cases, we do not talk here about residential scale. So we are going to talk about larger scale applications. So we talk about genset solutions above 100 kVAs of genset size. So that's the main task. We talk about the PV-Genset solutions. So use cases are in general utilities, off-grid regions, weak grid regions. That means if there is a grid available, you can integrate it in our system, but it's of course not 100% prerequisite to have a successful Fronius PV-Genset solutions. Also, a common use case we are facing with our solutions are remote industries. Just think of any mining and oil and gas drilling. That also makes perfect sense and is a perfect match where we can integrate a PV-Genset use case. Real estate and other applications, so there is a big variety of different use cases. I've mentioned here a few cases like hotels, warehouses, office buildings. So principally every applications where you do not have stable grid, unreliable grid, or complete off-grid, there you have got perfect situation, perfect match to our PV-Genset solutions. What are the core components? We have had it on the first slide so far. So of course, on the main heart is in the middle, you can see here. That's of course the diesel genset that has got at any time the highest priority within the system. So it's the main task to protect the diesel genset and to guarantee a stable operation of the genset. What we want from Fronius side to include is of course our inverter, our PV system, because that makes technically and also economically very, very useful and makes a lot of sense. And we have got from Fronius with our inverters the full compatibility to such systems, and therefore a lot of references outside. We will come into detail about that later. But to guarantee this perfect interaction, we need at some point, of course, controlling mechanisms, because you just think of such an overall system, it's getting kind of complex together. In order to guarantee such stable operations and this perfect match of PV and genset, we have got the solutions. For the easy version, we have got the Fronius PV system controller. And when it's getting more and more complex, we have got reliable partners like Elum Energy, and we will point out today these solutions. So the advantages are very, very different and have different roots more or less. So, but the biggest advantage is of course return on investment. So money is of course always important when it comes to such a system. So PV-Genset solutions are a real business case in higher irradiation areas. That means often these solutions are built in countries where there are not this good infrastructure and this good transmission lines, and therefore you have got a very, very high return on investment. Also cost reduction and risk reduction. On a genset-based grid, you're all the time reliable on fossil fuels, of course. Or often, if you think on remote areas, there are long distances, long transportations required to refuel your genset. And therefore, you want to reduce the costs on the one hand on the transportation and on your fuel costs to run the genset. What is also becoming more and more important is independence. That means in such a system, you can be completely independent from the grid if it's a complete off-grid system. So there is no dependence on the electricity grid. Just think of some remote areas where you have to the greatest extent of the day no energy or not that much energy you are requiring for your processes. That really makes you independent and you have a perfect solution there. And the payback period, I will show you a really, really impressive example. And that's also the case for different applications. They are really, really low payback periods and therefore a high return on investment. And this is such a solution we already implemented here with Fronius together. So just think 1 kilowatt hour generated by a diesel genset costs you round about 25 euro cents, and 1 kilowatt hour for a PV system costs you roughly 10 cents. So you see there is already a big gap between electricity generation from PV systems and diesel genset, that means from fossil fuels, and therefore I know at the moment the fuel prices are a bit declining, but you get kind of independent with such solutions, and there is a gap because a PV system is with the lowest levelized costs of electricity, and it's getting cheaper year by year. In this concrete example, it's a PV plant size with 144 kilowatt peak and a very good yield, yearly yield of the PV plant. And just look at the savings. That means if you compare the costs, the capital expenditures to the operational expenditures, you get below the line amortization within the 6th year. That means that is really, really fast and a real business case. And that means from the 7th year on you save around about 60,000 euros per year. And I think that's quite massive savings and really boosting your return of investment with the PV genset solution. Good, that was kind of the overall introduction to PV genset solutions. So now we will directly head into the system design with Fronius and also Elum genset solutions. So how could such a system look like with our products and solutions? So often we get the questions when it comes to PV genset systems, what is the optimum PV system size? In this slide, you can see that's a typical daytime a whole day of such a PV genset system. And you have these 3 components again, which means the light gray one, that's the genset load, the dark gray one behind, it's the effective load of the company, for example, and the red one is the PV integration. What I want to tell you with this, that in this configuration, the PV system is considerably small compared to the load and the genset. So you see the PV system generation is at no point exceeding the load demand of the household. And therefore, we at Fronius say, or we give you a recommendation that this is no cost-effective form of optimization, because you see here at the calculation, you just need 20% of the total energy demand, and that's a low penetration system. And regarding cost effectiveness, you're kind of leaking behind with it. What we want to tell you, again, a slide, what we highly recommend is to make bigger PV systems. That's the case here again. You see now the red line is much higher. The PV system behind this system is much bigger. And therefore, we strongly recommend such high penetration PV genset system. So such a curtailment, that means an oversizing of the PV system, makes totally sense economically, because the genset minimum load has to be obeyed, of course. And you can see here with regards to this calculation that you meet kind of higher percentage of the energy demand of the load, that means up to 40%, and have therefore, of course, higher savings. And of course, you have a faster return on investment with such a system. The only thing you need, of course, here is kind of a regulation, because you see here, there are parts of the day, there may be 1 hour, 2 hours, where the PV system energy, which is coming down from the PV system, exceeds the actual load, and therefore we are in need of such a controlling mechanism. Yes, you see it, the control of the PV production is necessary. And therefore, we have got 2 different possibilities here at Fronius, which I've listed up here now, that is always basically depending on how much gensets you have got in your system. On the left hand, you can see that's the PV-Genset easy solution. That's perfectly suitable for a single genset grid. That means typical low voltage application. You see here, 1 genset is integrated. Therefore, we have got our Fronius PV system controller, which has got perfect integration in this system topology, makes it possible, of course, with this easy solution. And then when we are talking about more complex system and maybe also more bigger systems, we are talking about PV-Genset Advanced and also Professional, but I have now talked here about the advanced solution. Therefore, we do not have the product. We are therefore relying on good partners, and that's today the part when it comes to multiple genset control. We are relying on Elum energy. We have very good experience with Elum energy when it comes to low voltage to medium voltage applications, and we have a multiple genset system which has to be controlled. Yes, and only coming back to the easy system, this multiple genset solutions, Lucas will tell you more in his part. I will now quickly focus on the easy system. So, you know, if you only have 1 single genset, the Fronius PV system controller, which you can see here, is therefore the first choice, of course. What can we do? We can ensure a consistent power balance. That means we all the time watch the load situation. We all the time watch the genset production, and therefore regulate also the PV system. It's a very fast regulation, which is of course necessary to avoid any prohibited operating points, and in order to guarantee stable operation mode and to extend, of course, the lifetime of the diesel genset. That's number 1 goal. I've only put here one quick graph I want to show you, which demonstrates you how fast this controller is regulating. Just look at here, bottom up. Therefore, you can see the minimum genset load. That's the genset, which is all the time at 30%. That means 30% of the loads are all the time supplied by the genset. That's depending also on the genset manufacturer, but most of them tell that a minimum genset load has to be met of 30% of the load situation by the genset. And if there is, for example, a sudden load rejection here, but on the other hand, you would have good PV yield at the moment, the controller has got the main task, of course, to protect this genset, and therefore he regulates down the actual PV. It means that happens within very, very few seconds, and therefore you have got again this stable operation mode of the genset, which has, of course, highest priority within this system. Just one quick graph. And yes, of course, we already have many applications on a global scale. We have got the tailored solution for each project. That's quite a recent project I received from a colleague last week. That's a tobacco farm in Zimbabwe. You see here the technical details, 80 kilowatt peak system, 150 PV-Genset, which you can see here in the picture below, and with the genset controlling is done by our Fronius PV system controller. And you see here the savings. So 100 liters of diesels per day can be saved by a simple integration of this PV system. And yes, but also a little bit larger applications are possible. So that's an irrigation purpose for vegetable cultivation in Lebanon. You see here the system size is bigger and also the single genset size is bigger, and therefore we also implemented the PV system controller to control the genset, and we can have also very impressive features, special features with 40% of self-sufficiency rate, and I think this is a key pro of the Fronius PV system controller. Okay, that was so far to our solution, the Fronius PV-Genset Easy. But I told you, when it's getting to more complex situations, when it's getting to multiple genset solutions, we all the time need a partner on our side, and therefore we will now point out the key compatibilities Fronius and Elum energy. That means for a bigger and more complex system. So principally, we currently testing in our R&D the compatibility, and I also received good signs so far from our R&D department. So as it is a rather new collaboration, I would say, we have got the compatibility of our Fronius snap inverters with the Elum e-power control series. So what you can see here, for our commercial applications, we have got our big snap inverters, the SIMO, starting from 10 kilowatts to 20 kilowatts, and also our big cost-optimized project inverter, which is the Fronius Eco from 25 to 27 kilowatts. So we are compatible with the Elum e-power control series. So how can a Fronius and Elum system look like now? You see here, I have pointed it out now with the Elum e-power control HFS. So we have got here a multi-genset system that can be now islanded mode, or also grid-tied mode would be possible. So therefore, we are relying on the Elum component. Lucas will point out more, but that's kind of the basic scheme, how such a system looks like in principle. Setting up the system, that is, I think, very important for you. So 4 easy steps to set up a successful Fronius and Elum installation. So first of all, there's of course very important the planning. That means you have to plan the communication architecture and via the slave devices. It means there is a real good guideline from Elum Energy where everything is clearly listed. Just follow these steps regarding the communication. I will also point out the key facts in the following slides. From Fronius side, I can say that we have to connect and configure the PV inverters, of course, our SIMO and Eco inverters. And then we come to the Elum part. What is very important is the autonomous wiring and installation. So there are no special technicians needed for such an installation. So principally anybody can do it, of course, and it's a very easy configuration. We will look on this. And also the functional tests. This is always the last step. So to prove, of course, your settings which you have chosen, and to check if the system is working properly. From Fronius side, I can just give you the hint that you have to, in many cases, of course, you have multiple Fronius inverters because the Eco has got as a max 27 kilowatts, and such systems tend to get bigger, of course, and therefore you have to interconnect multiple inverters. But that's really, really easy and possible with our SolarNet connections. I've put in here a slide. That means our inverters are interconnected via a Cat5 cable, a network cable, and therefore, yes, that's a specific protocol, the Fronius SolarNet. Some settings have to be made on the device itself via the display. That means you have to address the inverter and define one master inverter, which is sending the valuable data via our data manager. And on the end, just put it because I often get this inquiry also from tech support. Please do not forget these termination plugs at the end. These are 2 plugs. Otherwise, our ring wouldn't work and you will get an error message. You see here, that's another view at our inverters. Here is this SolarNet ring. So you go from SolarNet in to SolarNet out, of course, and at the end you have this termination plug. And what is also very important when it comes to the connection to Elum energy is this data manager. So our inverters are equipped with a data manager, and therefore this one is important for the communication. Yes. Which settings have to be selected? So that's our settings when initial commissioning. Therefore, we have also prepared it perfectly for such off-grid purposes. We've got an own microgrid setup. So microgrid 50 Hertz and microgrid 60 Hertz. These are extended voltage and frequency limits. You can see it here. You can choose it at the beginning. That means at initial commissioning. You just have to click through the inverter, and therefore can choose this setup, and you're perfectly prepared for the connection to Elum energy. And what is important when configuring with Elum energy? So therefore, we of course need the communication with Elum. It is very important to collect the active power output measurements and also set the right output set points. And therefore, we have to collect the accessible measurement useful for the monitoring of the operation. And what is, I think, key fact is the requirements of the inverter. That means we are communicating via Modbus TCP or Modbus RTU, and all the settings can be done via this communication terminals. And we from Fronius are perfectly prepared. We have these communication protocols, and you can easily integrate it in the system, of course. Responsible from Fronius is this data manager. This has got all these communication protocols. I've mentioned it before. So we have got the full visualization through our data manager and this Modbus TCP and Modbus RTU, which is so important when setting up with Elum energy. We can support these protocols, of course. How does this look like? I've quickly a drawing for you. So you see here Modbus TCP JSON protocol or the Modbus RTU, and therefore you can go via router to the e-power monitoring from Elum energy, or also it's important to get the data also in our Fronius Solar web portal that looks like this. Maybe you have already seen it, and therefore we have this combined view also in the e-power monitoring. Lucas will go into detail about it afterwards. Just a screenshot I received from a colleague from the R&D department of the wizard from Elum energy. So it's very, very easy. It's a step-by-step approach. That's how it looks like at Elum energy. And you see here that are our inverters in this configuration for inverters are integrated. So it's very, very easy, and I think you can do it quite easily. You can autonomously, that's no big thing. And the only settings at our inverter interface are therefore needed is the data export via Modbus TCP in this definition we have chosen in our R&D department, and that's really very easy wizards to have a successful cooperation. Last slide from my side. Of course, we provide you best support from Fronius. So we are worldwide operating, of course, also currently also expanding our markets. Of course, we have a good network of so-called Fronius system partners. That means they have real expert knowledge also on your PV-Genset system design, and they definitely will help you in any belongings. Just check the next FSP near you on our homepage. We also have in various countries technical sales advisors. That means we have 34 subsidiaries at the moment, growing of course, and in countries where we do not have a subsidiary yet, we have such technical sales advisors. These are people who give you technical advice, of course, and can also help you in genset belongings. And we have got this global network, and as we are a global operating company. And our tech support, I think this is also very important. We have got a real highly appreciated tech support, 24/7 tech support hotline. That's the future, of course. It's totally free access from any parts of the world, and you get really immediate help, individual help for your system you are configuring. And therefore, that's a real high benefit, and we have really technicians behind the phone who give you help in any belongings. Okay, that was it so far from my side. I now will give Lucas the rights. Thank you very much. I will also turn off my video cam. Lucas, do you now have the rights? Can you hear us?
Yes, I can hear you, Sandro. Thank you very much. So now I'll just start the screen share from my end. Okay, so you should now be able to see both my presentation, but also me. The camera just been turned on. And now we can move on to this part about Elum company, Elum products, and about our different site typology where we can install a controller, and also about some references with Fronius. So here you can see the agenda for today. So we'll start with a slide presentation about the company overview. Then we'll move on to PV diesel hybridization use case to follow up a bit about what was presented by Sandro in this first part. And then I'll show you what are the different products of Elum, which product can be used for what kind of site. And we'll finish with some hybrid fuel saver use case, which is the system of Elum that can be used for PV diesel integration with multiple gensets. So what was called as an advanced site setup by Sandro in this first part. And last, I will just show you some references and partnership sites with Fronius. So company overview. Elum Energy has offices in Paris, Casablanca, and Cape Town. We work in different regions of the world. We're really a global company working in more than 30 countries and with more than 50 sites that were commissioned yet. We have different partners all around the world. We can work with EPCs, but also project developers, but also inverter manufacturer, just like Fronius. Then here you can find different use case, different application for our products. We have first, of course, this solar power plant management, thanks to Elum energy management systems. which we'll be focusing on today, but we also can work on telecom application with monitoring and remote control solution, and also with industrial submetering solutions. But if you want to know more about this, you can still go to our website on our LinkedIn page. The key aspect of Elum product is that we are hardware agnostic, and we have this real perk about standardization in the process and commissioning. So it means that we'll be able to work in different site typology and different projects with Fronius inverters, of course. And on the genset side, of course, we can work as well with different brands of genset controllers, different equipment. So a few of them are mentioned here, but this list is absolutely not comprehensive. And if you want to know more about our genset compatibilities, you can ask our teams later. But we're also compatible with many different brands on the BSS side, so with many different battery inverter manufacturers. So now let's talk about PV-Genset hybridization and follow up a bit with what was said in this first part. The Elum controllers can be installed in different systems where we have different advantage and different perks. So of course on microgrids and solar diesel hybrid plants, on any energy distributed network with different power units to be managed live to ensure a high PV penetration and to reduce fuel costs. So we can start with the pro-grid system setup. We basically have two different system setup, the pro-grid setup and the off-grid setup. The pro-grid setup is a system where most of the time you have the public utility being the mains, but we have this grid that is very sensitive to load imbalance with a lot of frequency fluctuation, and it happens that the grid fails. So when the grid fails, you have those gensets that automatically turn on to ensure that we still have some energy being produced on site, and so that the commercial and industrial activities, for example, can continue. If you don't have any PV-Genset controller installed on site during blackouts and when the gensets are turned on, you won't be able to produce energy with the inverters. So it's key to have this PV-Genset controller to ensure a continuous PV production all during the day and during on-grid and off-grid modes and when we have those blackouts. So here, for example, you have an example of a classic pro-grid setup. You can see here that we have the grid on the one hand, but also the backup gensets and the rooftop PV plant, or that can be also any kind of PV plant connected. So also on this slide, you can see that you have this e-power control component here that is connected to all of the different power units. So it's very important to know that Elum product is quite particular because you have this e-power control main component installed on site that is physically connected to each of the power units to be monitored and controlled, and that operates the system live. So it means that you have this main component that is autonomous, that can be operating also during grid outage. We have UPS, but also during internet outage. You do not need this component to be connected to the internet to manage your site. Still, this equipment is connected to the internet when the internet is available, so that all the different data about the different power units can be sent to our ePower Monitor platform. The ePower Monitor platform is a full cloud service that can allow you to proceed to the kind of operation analysis, to have some KPIs for your power plants, and be able to just manage your plant remotely, thanks also to the alarms monitoring. You'll be able to access both live and historical data. So what are the different features of this e-power control unit that is installed on site and that manages the system both during grid tide and off-grid times? So basically, when we are connected to the grid, the e-power control will be managing the power output of the inverters live to ensure that there is always this grid feed-in management. So for example, in some different project, we have this constraint about the feed-in management not being able to export energy to the grid. So the e-power control can ensure that no power will be exported to the grid. Then we have, during blackouts, of course, the genset that are turned on to ensure that the energy, the correct energy flow is fed to the load. But the e-power control will be managing the inverters again to ensure that we have as much energy as possible that is produced thanks to the PV inverters, while ensuring that we always have this minimum genset loading on the genset side to ensure the safe management of your genset power plant. So for example, here you have different grid-tied application for commercial and industrial buildings or fuel station, banks. For all of those sites, you have this key aspect of and key like problematic that is take of being able to have the load that is correctly fed by some reliable energy source at any time, almost 24 hours per day for fuel station and banks, for example, or during the daytime for CNI facilities to avoid any loss in the production. So now we can move on to the off-grid setup. So the off-grid setup is a system that will never be connected to any like public utilities. So it is always connected to gensets, but also it can be connected to a BSS system. Off-grid systems also need an EMS controller to ensure that at any time you are producing as much energy as possible thanks to the PV system, so increasing the PV penetration, but also ensuring that you are limiting fuel expenses at any time by managing the BSS system also correctly, ensuring a correct spinning reserve, and all those features I'll talk better in the next slides. So here you have an example of a microgrid that is totally off-grid with different gensets, ensuring that, not ensuring, but like being the grid forming units with the PV plant connected. So basically we have the HFS controller that will be managing this PV diesel plant, but we can also propose products of the e-power control portfolio that will be able to manage BSS as well. So it's very important that our products can, of course, be installed on system with multiple genset and PV power units, but also with BSS system to improve even more the PV penetration. So what are the different features of the power control on off-grid configuration? First of all, you have this spinning reserve optimization. So basically it's being able to turn on or off different power units to ensure that those different set points are configured, that we are using the BSS properly to ensure that there is no loss in the PV production, but also still to ensure that we have this minimum genset loading on the genset side. Which is really key for the safety of the plant and to ensure that you can use those gensets in this off-grid configuration. The Elum product e-power control is also able to manage diesel gensets to be turned on or off according to the site configuration and to the load current demand. And for example, if you have 4 different genset units that are running at a moment when only one genset could be used because you have, for example, an important PV production that is available, we'll make sure that you have only one genset being turned on, ensuring you are running this genset at a more efficient loading. So we have all these control strategies that are a bit more complex and a bit more about optimization for off-grid application. So here you have, again, some different study cases and application for off-grid configuration with, for example, rural electrification in remote areas. but also some system with much more PV power being installed on site with power station, but also utility scale projects. Here we can, of course, manage the whole PV plant, even if it's more than multi-megawatt size. And if there are multi-genset installed on site, of course, the power control will be able to manage all of the different gensets to ensure that all of the different gensets are controlled properly according to the strategy that was defined. So here we will see the product portfolio of Elum. We have different products adapted to different sizes of project, also different typologies and different problematic that can be at stake on each project. One of the first products is the power control SD, which is more similar actually to the one genset configuration that Sandra was talking previously. So we'll not go deeper into the details about this, but we will talk about the power control HFS. The power control HFS is this product of Elum that will be able to manage some multiple genset sites. It, of course, ensures the data logging. So it is connected to the ePower monitor platform, cloud services, thanks to VPN access and internet connection. But it is on site, physically connected, as I said, this ePower control to different sensors. If you have, for example, some performance ratio to be calculated, we can integrate any monitoring weather station or any system that is necessary to be monitored. And of course, we have this connection with the PV inverters. So when we're working with Fronius, we will be connecting directly to the data manager and communicating over Modbus with the equipment to be able to control the PV inverters at any time. Then we will be connected to all of the different gensets to be monitored and controlled on site. So those gensets will be integrated again over Modbus communication, but for some specific site, for some specific reason. For example, you don't have the right to connect to those gensets. We can also monitor them through some power meters and to control the PV inverters according to those monitoring of the genset that is made by the power meters. So again, we have really this cross compatibility with different site typology and different site constraints on the genset side. Then we will also need to install some power meters on the load and on the grid to be able to manage the site both during grid tide and off-grid times when we have the blackout, but also when we have to ensure that there is no energy being fed to the grid. Here you have an example of a system integrating battery PCS, but this is not really the product we would like to highlight today. There will be more webinars coming up soon about this. So I'll just pass briefly, but again, we will be connecting to each of the different units on site thanks to the ePower control component, and all the data will be, of course, sent online to the ePower monitor platform. And we have also this last product, which is the ePower Control PPC. That is a product that is fully custom. And actually, this is a product for upper scale project, multi-megawatt utility scale, where we are developing a custom strategy for you to manage your power plant. So this is a bit more complex, but it's just so that you can know that Elum Energy have engineers that can prepare and work on project more complex and custom project and propose controller also. So here I'll just go deeper into the details about the Elum configuration interface and Elum SCADA. So on this ePower control component that is installed on site and that is really like physically connected to all of the equipment, you have an integrated Elum configuration interface available. This Elum configuration interface is available anytime from the commissioning to like anytime during the operation and the maintenance of the site, and you can access it just by connecting a computer physically to this ePower control with an Ethernet wire. Like this, you will be able to proceed to the autonomous commissioning of your controller, being able to make some connection tests during the first installation, being able to for example, configure the minimum genset loading at different set points, make some special arrangement with the local team. So you're really like able to manage the control strategy and this e-power control unit thanks to this interface. Here you have some different screenshots of this interface. So for example, the screenshots were made from a system that was already commissioned. So for example, here you can see that you have the solar inverters, live production, how many power is being drawn from the grid meter. You can see if the power units are being curtailed now, what is the status of the system, if there are any active alarms. You have also access to all of the different material alarms directly on site. So for example, if you have an internet blackout and you are not able to access your site remotely, the technical teams are able to go directly on site and connect to this Elum configuration interface to access the live monitoring data and access also to the active alarms. If you need any troubleshooting, you'll be able to still access those data if you don't have internet connection. Here, for example, you have some other screenshots, so giving you the status of the different power units being connected to the controller. You will be able to manage locally some different set point that you're able to edit, and also just check some different values that are being monitored live. Also, again, check the active alarms on each equipment. And of course, you'll be able to manage the network. This is a plus for you because, for example, if you commission a PV diesel system that is operating, for example, on backup application, you have commissioned the system with, for example, 4 or 5 Fronius inverters, and that it happens that 2 years later, the load demand and the load profile has changed, and you want to integrate more PV inverters to have more PV production. You are able just to commission again your system autonomously, install your Fronius inverters and connect them to our system. Just configure them directly from the Elum configuration interface and continue operating your plan. And like this, you have like really like the full control of your site. You are able to manage the site during the operation and maintenance at any time, and you are able to manage those evolutive sites. We know that in different region you have those low demand, and different projects you have these different like load profile that are very like evolutive. So you will be able to do this autonomously. And for example, here I took the example of PV inverters being added to the system setup, but you can also add, for example, 1 genset or 2 genset. You can change the genset that were associated to the system if, for example, for any reason you had to replace those. So here again, you have another screenshot of the solar controller configuration with the application, the association of the different power meter, the genset configuration, and minimum loading configuration. So now let's move on to the e-power monitor platform. So this is the platform that will be accessible from the web, from any web browser, actually, from our dedicated website. And you'll be able to manage not only one, but all of the different sites you've been commissioning with Elum, with this like more portfolio overview own platform, but you will also be able to manage each of the sites independently, accessing historical and live data, having some very precise information about inverter status that allows you to have some like really like a full overview of what is happening on the site, on your site, even if you are not physically present. You also have these wall alarm tools that are proposed by Elum. So again, all the different faults and warning that were triggered on site on any inverters or maybe on the gensets about the fuel level or about maybe the voltage that is too high at a certain moment. You can have all of those material alarms triggered and notified directly from the Elum e-power monitor platform. You are able to activate email notification again as well if you have some very critical alarms you want to be aware of if they are triggered. And you are also able to set up some custom alarms. So by setting up some custom alarms, you'll be able to select a specific device, a specific value, or kind of, yes, any register that is monitored from this device, and apply some condition so that the alarm will be triggered and be able to like fully manage your site according to your needs. So now let's move on to the hybrid fuel saver, one of our important references, which is a medical research center in Gambia. So here, for example, we have 500 kilowatt peaks of PV with different subsites on the PV end, many inverters, but also 6 different gensets to be managed. And currently on this site, we commissioned, it was an last year we commissioned, actually it was last summer, we commissioned our hybrid fuel saver controller that allows the management of the site. So the feed-in management when the site is grid tied, but also the genset, minimum genset loading management during off-grid times and blackouts. Here you have some interesting screenshots about how the system behaves when the power control is installed. Here in orange, you have the load. In blue, you have the green. And in yellow, you have the PV production. So you can see that around 9, the PV production is equal to the load and could potentially even be higher than the load. So at this certain moment, the e-power control curtailed the PV production to ensure that at any time this PV production does not exceed the load demand. And you can see here that almost no energy was drawn from the grid because the PV production was enough to supply the load demand. And you can see that, for example, around 1 o'clock, when the load like increased steadily, and it was also the moment when the PV production went down, the grid, the energy being drawn from the grid is increasing, and the Elum controller is not curtailing those inverters anymore. And here you have another example of the e-power control managing a system. Here it is a backup application for per grid, and you can see that in blue now you have the gensets power. And we can see that around 1, there was this grid outage, so the gensets were turned on to ensure that we still have some energy flow to the load. And actually you can see in this like light blue the genset target load, which was, I believe, 30% for this site, and that the genset power is like absolutely equal to the genset target load as long as the load is higher than this minimal genset loading, and that all the additional power like necessary to ensure that the correct energy flow goes to the demand is being supplied by the PV inverters from 1 to 5. So now we'll move on to some other references, maybe going less into the details, but these are still some important references of projects that were commissioned yet or that will be commissioned soon with Fronius inverters. So here you have example of gas stations. So we are here in some e-power log application, which is a data logger of Elum monitoring the PV inverters of Fronius, but also the genset, the fuel level sons as well on site. We have different project of gas station in Nigeria, Morocco, working with different PV inverters, distributors of Fronius. So this is an example of monitoring of gas station, but we also have some example of control sites. So here, for example, the microgrid controller of Elum was installed to control the PV system, the gensets and the battery on this microgrid in Morocco, where we work with Clean Energy, a Fronius distributor in Morocco. And the Elum controller is ensuring that at any time we are maximizing the PV penetration and controlling the system correctly according to like the actual PV production that is possible, and the energy being stored in the batteries, but also the minimum genset loading and all those problematic that are stakes in microgrids, as I said before. Here we have another example of a system that will be commissioned soon in Peru. It is a bit more important in terms of PV capacity. We have 500 kilowatt peaks here and 5 different gensets. But there is also an hydropower unit that will be managed just like a grid, just like a pro grid that is not available 24 hours per day. And so sometimes we have to turn on the genset to ensure that there is enough power being to the load. And the load here is the whole city of Atalaya. So the hybrid fuel saver that will be commissioned this year by Elum Energy will manage this power station system feeding the whole city. And we are working with Novum Solar, Fronius distributor again. Fronius inverters will be installed here. And last but not the least, we are also working now with Fronius R&D Lab because the R&D team is like making like just working on the approval process of the hybrid fuel saver to certify the product, that the product is conformed to Fronius standard, as said Sandro before in his part of the presentation. So this is my last slide actually. From my end, that was all, but I think that now we'll move on to the question and answer part where we can interact with you and answer some of your questions.
Yes, thanks a lot, Lucas, for your very, very interesting presentation. So I think we are a bit over time, but I do not want to miss the possibility, because we have a massive audience today, to point out the most frequent and most important questions. So maybe my colleagues on the other end of the line, Mr. David Hanek and Christoph, did we receive any questions during the webinar? I guess so.
Hello, everybody. This is David speaking. So I've been in the chat today, and as Sandro said, yeah, there have been quite some questions related to this webinar. That's cool. There have been a huge amount of participants as well. I'd like to pick out 2 questions which have already been answered within the webinar, but just to point it out for everybody. So there has been a question or demand for storage systems, and I just wanted to point out here once again that the PV-Genset easy solution that we have is not able to work with battery storage. But for the PV-Genset Advanced and Professional solutions, as Lucas already explained in his part of the webinar, there's of course the possibility to incorporate batteries for maximizing the fuel savings actually. It makes sense if there's too much PV power in the system and you need to curtail this power. It's way better to store it into the battery and use this later on. So just to make sure, or just to point that out once more, the PV-Genset easy solution is not cannot be used for incorporating storage, but the advanced and professional solution, they do offer this possibility. And then there was another question which might be interesting. It's coming again and again. This is about communication between the gensets and the inverters. What if there's a long distance to cover? So we all know that Modbus RTU lines, they do have some restrictions in length. We also know that TCP IP lines have some restrictions. So our recommendations, if you have to bridge more or less longer distances in the range of kilometers, is to use like gateways, converters, and move on via fiber wire cables, for example.
Okay, David. No, please continue, David.
No, that was it. That was it from my end. I think all the other questions have been covered quite perfectly during the webinar.
Okay. Do we have any question to Lucas from Elum?
Yes, so this is Christoph speaking. Hello. Yeah, just wanted to point out 2 or 3 questions to you, Lucas, regarding Elum. One of the question is there actually a maximum of genset that can be connected to a hybrid fuel saver, to a HFS?
Thank you for this question. Actually, I do know that there is a limit, but I have to check exactly the data sheet just to confirm that to you. So maybe I can just send you like the actual very precise documentation about this. But for example, in the reference project I showed you in Gambia, we have 6 different gensets being integrated. And I know that in our project pipe, we have many different projects with up to 8 gensets. I didn't see any personally any site with more than 8 gensets, but I think that's better if I just come back to you about this very precise question later. But for sure, if you have less than 6 gensets, we'll be able to manage it.
All right, thank you. And maybe one last question. Is it possible with Elum controllers to do a PV-Genset system also with battery solutions integrated?
Yes, actually, so this is what I was explaining before. We can integrate batteries, but this will not be the same product as the power control HFS, which we were highlighting today, which is a product which we're collaborating with Fronius on. But this will be the power control MC that again is compatible with Fronius inverters. But this is not exactly the same product. And if you want to know more about this product, there will be some more webinars coming up. And you can just come back to me. I can share information for sure about this, and we'll be very happy to work on PV, diesel, and BSS system as well, because this is what the e-power control MC microgrid controller can do.
All right, thank you, Lucas, for answering. Before I hand over to Sandro back again, I just wanted to point out a very frequently asked question. All of you will get the recording of this webinar and the presentation within the next few days. So don't worry, you will be able to look it up again and to go into more detail. Okay, then thank you very much, and back to you, Sandro and Lucas.
Okay, thanks, Chris. Thanks, Dave. So far, we are already a little bit over time. I have quickly looked into the question box, so many questions are still coming in. So we will stay, of course, a few minutes online afterwards, and I will also help together with Lucas answering the questions. If you do not get immediate reply, we will send it to you afterwards via email. So far, so good. Thanks for your participation. Thanks, Lucas, for joining, and Elum Energy. I think it was very good content for your customers and also for our customers. Hope that we continue this very good collaboration, and I hope we hear or see us soon at a fair or at any other webinar we will plan in future. Okay.
Thank you very much, Sandro. Thank you very much. I was very glad to participate to this webinar with the Fronius team as well today.
Okay, then bye-bye. Thanks.
Thanks all. Thanks for attending the webinar. Bye.